So there's a problem with heating your house with energy to give you and helping the environment, but also costs and utility bill. And to give you an idea about how big of a deal this is, it's about 42% of your utility bill, which roughly corresponds to how much energy you're using. Now, yes, there's a bunch of factors going on this whole thing, since propane versus electricity, with how efficient the propane can in some cases be more efficient use of energy than other ones because direct heating and stuff like that, but sometimes electricity depends on where you live and location and so much more. However, one of the most efficient uses of energy that could really save a ton of energy is when you do a direct conversion of energy and you don't do all those complicated things. So if you're taking sunlight and turning it into turning into heat, turning into electricity, then turning into heat again, you lose energy. If you turn sunlight from a solar panel distantly into electricity, then into heating, you lose some energy. Now you can make it lose less with better efficiencies, with heat pumps, which can extract energy from the outside environment, with better plumbing and stuff. But you still lose a lot of energy. And then you also have the transmittance of this stuff. If you have propane, you have to bring up the propane to your place. If you have electricity, you have to carry electricity through all these wires and stuff like that, where some of the energy is lost, and so on and so on. So I want to discuss an idea to fix that with windows. Now, I'm going to discuss a couple of little ideas in part of it. One of the things is we can put windows with reflective coatings that reflect heat back into the house to cool your house, to keep your house hot. And doing that works during the cold winter months when you're losing heat more, because there's a heat difference, so more of the heat radiates outside of the house. During the summer, more heat radiates inside the house, and then a window reflects that hot energy away. Now, it's not a perfect system. There are times where the radiation is not exactly equal and it ends up heating up the house more, and you can design passive systems that are very complicated to get rid of it. What about a simple system? And also another thing I forgot to mention with heating is you could turn light that you don't see into, if you looked into turning into heat. You can see like a black thing turns non-heat light into heat. Not the infrared light, and I'm calling it heat light. So could we design a one-way system that heat can come in with light, but it cannot go out? And then one that contains light that you can't see into heat. Well, one way people have been looking into this is to put solar cells that you can't see that do this, but they first turn electricity, which loses energy. I'm proposing a simpler system, and you can also move these things up and down like a blind, so you can remove the system when you want to let more heat out during, let's say, the summer. And you could even reverse the system to make a one-way mirror during the summer to let heat out so it cools off faster, so it reflects the heat away and certain things, so even more adjustable, and it's reflecting also the heat back inside the house so heat can escape but can't come in as well. So how would we do, well, that's how it requires layers. How would we do this? Well, my first part of the idea is to have a bunch of little particles that scatter light, and the more you go down one direction, some point in this way, the more they scatter light. And if you do that precisely, you can make a mirror that only lets in certain wavelengths in one way. Now, this scattering the light, how stuff scatters light, the larger the wavelength, the bigger the structures these structures can be. And infrared is massively bigger than visible light you normally see, and you can make it that way. So you don't need to make it as precise for visible light, and we can make it also only scatters infrared light, so it only acts like a one-way mirror for that, so it doesn't affect visibility for the actual person. So each of these little particles scatters it. Now if we go in a forward direction where it's increasing, it slowly scatters it and bends it. Because scattering is kind of bending it, because some of the light goes in the wrong direction. It's kind of bends it, you can think of it, because it's moving in different directions. But this is a slow thing that slowly adds up, and each one kind of bends the other one a little more because it's a gradual shift. Now some of the light, when it's gradually shifting, actually bends and corrects itself. Because remember, when it hits this particle, let's see in the first layer, some of it scatters in a different direction and spreading out. But some of it by the next particle scatters back in the right direction. Some of it's going to scatter back in the right direction, which I kind of saw with this arrows making a curve backwards. And this cancels out, so it just goes forward more. But most of the light anyways is going forward. This is minor corrections in each layer. Each layer is just spreading out a little bit, but then it also corrects itself. Now, next you have a secondary effect. But if we go in this other direction, where there isn't as much of a gradual shift, where it's just a sudden big shift, when it hits the first layer of particles, most of it's scattered back in a reflection way. Boom, 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 boom. And then the next layer, a lot of it is scattered back into this first layer, which then scatters it in all different directions and a lot of it out. So it doesn't cancel out as much in one direction and appears more like a reflective mirror surface. Also, the other effect is from this surface, not only is it a bigger shift that forces more of it out, there's less distance to travel to get out than to travel along this whole thing, which also gives it a directionality. It's easier to escape when it's just scattering in every single direction, first of all, in a ton of ways. To further all these effects together, we can have we have something called the Huygens principles, and that's when a bunch of scattered waves from really small things, and the smaller the scatter source is, the better, and the bigger the wave, the better, because it's actually how small the particle is compared to the scatter source. These waves cancel out and make it almost a linear wave, where they can make any sense wave, these points. And this is just an illustration, because the high parts add up, the low parts add up, and the add down will make it lower. The high parts become higher, and then parts in between cancel out, and then you're just left with like a front like this. So this also makes it very effective here, makes a wave that just keeps going forward, because most of the momentum is, remember, still in the forward direction. So it acts like each particle that just scatters a little bit makes it almost like the wave is still traveling forward with energy. Well, here, when most of the wave hits it, most of the wave is immediately pushed backwards, and then it cancels out, so it keeps going backwards. So you have all those principles acting together. Now, in the place that on the side that's reflected, which I drew a little purple dots here, but to redraw it on the side that's reflected, if I put a bunch of dyes that you can't see, or substances that absorb light and turn into infrared light, which you can do much more efficiently converting into electricity, and then when you convert to electricity again, you have to convert to heat, so you also lose that and a piece of energy. You can then much more have this light just go back in and hit the inside, and also light, remember, travels from here inside and converts. You can even make these particles have some directionality with how they absorb and emit light by having them have certain cross sections that promote such activity. Beyond having such cross sections that promote such activity or directionality, because some stuff absorbs light over here, absorb and emits it over here. And actually you can make metal nanoparticles have this property pretty easily. You can do a bunch of other cool things, like if you add directionality with special shapes, with how it makes light, you could make this mirror better. You can do that with something called plasmonics, or stuff where you have metals that more easily absorb light, and they can act like a antenna that receives light more easily here, but then the vibrations doesn't mean it can't absorb light as well here, so it emits it more here in a certain directional way, or that it has certain shapes of that it splits or reflects light. And this why I'm sounding so general is because there are a million ways of doing this, which all have to do with various experimentations. Another way you could have it is if you have this one that lets in light out, and you don't have this absorption thing, you have a way to let heat out, but not the heat from the outside in a hot summer day back in. And you can move these blinds up and down on the side of the wall to readjust the heat absorption of the house and emittance. This could let you to have bigger mirrors. Now, in the future, which will be hard to design, you can make this also one way for visible light. The problem with visible light, though, is visible light has a lot smaller wavelengths, so it's a lot harder to design this whole system. But you might be able to do it to some extent. Now, the nice thing about having visible light is then people want to have even more mirrors in the house. Not mirrors, windows, to light up the house so they can save electricity. Also on lighting up the house with lights. And they can look at a nice outside world without having people spy on them. The problem with this system simply is what I said, but maybe one way around it is some of these mirrors might not work as well as to have a clear pixel side world, but you may be able to design it so it lets in a lot of light, but the light is more fuzzy, because then you don't have to design as perfect of a system. You could also do it in other ways, that you have this conversion of one type of light into another type of light, which can happen sometimes quite efficiently, and we're getting better at that. So you can convert all the light, green, blue, and everything into red light. I'm making up this example. And you could have a house that uses less red light, and the light adjusts so it's more of one type of light. And that could save a ton of energy, because you don't have to light up the house red. But it would also make the picture outside less clear, which is a big, huge advantage. They also can't see inside as well, because everything will just come out red. Or something like that. You can also use the plasmonics and stuff, like with the special materials, to shrink the scale so you don't have to be as precise. And you can make it more one way while increasing resolution. But also scattering might be sometimes preferable, because if you want light in the house, you might want more of an even lighting instead of being outside. And it also would help people with different types of light sensitivity, because it would make more of an even lighting instead of a harsh one-way lighting. And you would have to also worry less about the direction of light, because it's coming from all directions. See if some place is not well lit. And if you want to go really fancy, you can have mobile layers to control different types of light and everything. Combine this with smart lights that can detect what light your house is, and it might work really well. Another thing I was thinking about, also for heating house, is to have heat lamps to heat up part of the house. Because heat lamps can heat up surfaces more efficient, they don't heat up the air. So if they're shining on you, it actually will make you hotter faster than other ways, which could save energy, because it's just heating up you, not the whole house. The thing is, though, if it's not shining on you, it doesn't really heat you up as much. So it'll be something to maybe play around with extra, but it'll be a big extra thing. So it's like, I'm go back and forth whether that's an actual good idea. You could also combine this with all the other technology I talked about heating up the house to really get efficient. Well, thank you very much for listening. Please like and subscribe. It really helps the channel out. I'm trying to reach 1,000 subscribers in a year and 4,000 watch hours, which is really hard. With your help, I think I can do it. Also, if you have any ideas for future videos, comments, or suggestions, please leave them in the comment section below. Thank you very much again. Goodbye.